Hello, we are aUToronto from University of Toronto. In this presentation, we'll be discussing how to best maximize the return of investment on inactive personal electric autonomous vehicles. To do so, our team has developed a new way of utilizing this downtime for car owners by deploying vehicles to do business-to-consumer autonomous food delivery through a mobile app. Our pitch will outline how this implementation will create the greatest return on investment for the vehicle's owners.
To do this, the OEMs can first create a software-defined vehicle to be able to download food delivery features onto itself to enable switching into a delivery mode, and utilize a complementing mobile app that the owner can see status updates on and control their car remotely. The deployment of these autonomous vehicles for direct business-to-consumer food delivery will accompany the ever-growing demand for food delivery services and thus be a sustainable, high-profit method of optimizing vehicle downtime. In addition, the OEMs can develop a service center attached to all their car dealerships across the city to help clean the owner EVs and charge them to full, free of charge for further owner incentives. The OEM app would be a flexible delivery last-mile provider focusing on servicing the final user. Similar to DoorDash's models shown here, it employs a three-sided network model to integrate EV owners, restaurants, and food customers. It provides values to the EV owners by providing flexible working hours and a passive source of income, to the restaurants by an extended customer base and efficient transportation with fewer risks, and to the food customers by increasing convenience and quick deliveries.
We're targeting the food delivery market as it has a strong growth potential even into the future. The online food delivery market in the United States attained USD 18.5 billion in the year 2020 during the pandemic, and it is expected to reach a compound annual growth rate of 11% in 2025 from 2020, shown by the bar chart. Thus, this confirms that the food delivery industry will grow continuously into the future, even after the effect of the pandemic. Our solution combines the unique benefit of both by allowing vehicle owners to deploy their own vehicles to generate revenue while also drawing attention to its convenience, low emission, and social impact factors. As there are no human factors in the delivery process, this will also ensure that there will be no tipping costs and that there will be fewer mistakes, accidents, and lawsuits made. This will reduce the delivery time and the overall cost for the customer, becoming more competitive than pre-existing food delivery models.
Here is a demonstration of how the OEM app will work for the EV owner while in delivery. First, the owner activates the device and equips the car with the compartmentalization device. Next, the owner is prompted with an estimate of how long the car will be in delivery mode. The number of shipments and vehicle operation time can be optimized depending on the estimated downtime of the vehicle. Then, the vehicle proceeds to complete deliveries. Restaurants and food customers electrically open the compartmentalization device to deposit or retrieve contents. The owner is presented with the location of the car, its electricity levels, history of past deliveries, and updates on the current delivery status. In the situation where the owner requires the car before the deliveries are complete, the vehicle immediately heads to an OEM dealership to drop off the shipment, which will be picked up by another vehicle. Certain financial penalties will be charged to the owner to deter future interruption of the service. Once the scheduled time approaches, the car proceeds to charge to full at a local OEM dealership service center and return to its desired location. Finally, the compartmentalization device can be removed so that the vehicle can return to owner use, and the owner will be able to see a summary of their profits at the end of the day.
Setting up small service centers attached to the OEM dealerships scattered across the city will also provide a high value to the customer by ensuring that the vehicles remain in good condition. Although using autonomous vehicles for food delivery gives lots of benefits for the car owners and food service industries, there are still potential drawbacks. The increased usage of the vehicles will also impact its battery life, if not charged appropriately, leading to potentially greater maintenance costs. In addition, as these vehicles will be used for food delivery, higher maintenance costs may be required for the car owners to keep the car clean. These problems can be addressed by setting up regular maintenance services for the autonomous vehicles provided by the dealership centers. The dealerships can also promise to return the vehicles fully charged back to the owner, thus further incentivizing them to deploy their vehicles for food delivery.
The vehicle owner's net profit is outlined in the equation here, where the net profit equals the number of deliveries multiplied by the end customer paid delivery cost subtracted by the app tax cost per delivery. From this, we take away the one-time paid compartment cost, the cost of installing the compartmentalization device to the vehicle. By substituting estimated values, the equation to calculate the net profit for the vehicle owner is as follows. We estimate the delivery cost to be around $6.77 for a 10-minute delivery across 3 kilometers based off Uber Eats' current model, the app cost to be around 25% of that, and the compartment cost to be an estimated $600 to purchase. These values are all estimated but justified in detail in our report. To find the break-even equation, we set the net profit to 0. From this, to break even from the compartment installation costs, the vehicle will need to make around 118 trips, depending on the overall actual cost of the compartment device. Going back, keeping all our previous values the same and substituting a rough estimate of the vehicle making an average of 20 deliveries of 3 kilometers per day, we get this equation. As you can see, we can estimate that the vehicle will be making around $101 per day without any bonus incentives. Here's a graph of our estimated profit per hour for a full day of deploying the electric vehicle. We're keeping peak delivery hours and average owner usage hours in mind, averaging 20 deliveries daily. By multiplying this by the number of days per year, the vehicle is expected to make around $37,000 per year. From these estimated profit values, we can conclude that the vehicle owner will be incentivized to deploy their vehicle for our implementation due to the forecasted high profit. While the overall profitability may unfortunately decrease as more OEM delivery vehicles are deployed, this is just a rough estimate forecasted from the current market situations. However, we are optimistic that even with our higher-end estimates, that our vehicle will still provide a high passive income for the EV owner. However, it is also important that the OEM sees a profit in this implementation. The cost model for the OEM is shown here, where the net profit equals the number of vehicles in deployment for a full day multiplied by the profit made from the daily app tax subtracted by the daily charging cost per day to charge an electric vehicle to full. From this, we take away the one-time cost needed to create a food delivery platform application. Substituting in estimated values into the equation, with the daily app tax cost being around $33.8, the charge to cost the vehicle to full being $30, and the cost to create the app being $150,000, the net profit to break even for the OEM is shown here. Thus, there will be around 39,500 full vehicles deployment days for the OEM to break even, depending on how much it costs to build an application. As this program expands, the OEM will still be able to break even if more than 110 vehicles are deployed for a year.
There are some facilities that are already developing autonomous vehicles for the sole purpose of delivery, but this could become a burden due to the need for greater production of electric vehicles to sustain this new development. Introducing new vehicles for delivery-only purposes will create even more battery degradation worldwide and more congestion on the roads. Therefore, using pre-existing personal autonomous vehicles that can also be substituted for food delivery reduces the need to produce additional autonomous vehicles for just this purpose. This will thus promote environmental sustainability and infrastructural sustainability. The main strengths of our design are profitability for both the owner, restaurants, and the OEM, the potential for a strong consumer base leading to a network with expanding effects, lesser insurance, lawsuits, accidents, and greater convenience for businesses and end consumers. Additional opportunities that we can look into exploring are expanding to more delivery markets, such as maximizing the use of off-peak food delivery hours at night to do parcel delivery services instead. Some threats we see are possible public pressure from pre-existing delivery human drivers and a potential decreased profitability as autonomous delivery services become more competitive and widespread. An OEM should support this pitch as implementing personal autonomous vehicles for food delivery will deliver high profit margins for the owner and thus maximize the return on investment. We are hopeful that our solution will best create the greatest benefit for the user, OEM company, food delivery, customers and restaurants, and of course the vehicle itself. You can find more detailed information about our implementation in our report documentation. Thank you for taking your time and watching our presentation.